Hello all, welcome to another LeetCode problem. So today we are going to solve problem number 1818, minimum absolute sum difference. So in this problem, if we read the problem description, so there are two arrays given, nums1 and nums2, and then we have to minimize the absolute sum difference of an array. So if I take nums1 I minus nums2 I, and then if you take a difference and then sum of each element, so you have to minimize the total sum that you get. But condition is what is the process you need to take, how to minimize it. So you have to replace at most one element in nums1 with any other element in nums1 to minimize the absolute difference. So let's understand by example. It's bit challenging initially to understand. So let's say this is first array and this is a second array, right? Now if I take some difference here, let's say 1 minus 9 and 10 minus 3 and 4 minus 5, likewise that, right? And then the absolute sum difference will come to as 27. Here it is not given, but I'm just telling because I calculated. So if you take any first element of nums1 and first element of nums2, and if you subtract the resultant, you add it to the resultant that you get from subtraction of second element of nums2 and second element of nums1, likewise. So you get the total difference is 27, but the output of what you're getting is 20. So what they are saying, okay, you replace one of the element in nums1 with any other element so that you can reduce the absolute sum difference to 20. So what they are doing is, from here they are replacing 1 with the 10, so that the absolute sum difference they are taking is coming as 20. So we will go through the example how we can solve this problem, and then we understand what is the best way we can achieve this, right? So here we are given an array, so same example that I have taken. So they are saying the nums1 is this, and then nums2 is this, right? So forget about at this moment how do we reduce the absolute sum difference. But if I take this absolute sum, right, so what I'm going to get is, so 9 minus 1, so 9 minus 1 is 8. So I'm going to take the absolute sum differences, and then I'm going to sum it up later on. So 10 minus is 7, 4 minus 5 is 1. So I'm taking absolute difference, right? So I'm ignoring the negative one. 4 minus 1 is 3, and likewise. So sum is coming as 27, right? So that's the total sum. But now we want to minimize the 27 to 20, right? So in the example it was given to tell that if you replace 1 with 10 here, which is next element here, right, then what is going to be here, right? So difference will come as, instead of 8 it will come as 1, right? So there's a difference of 7, right? 8 minus 1 is 7, so the total will be 20. But the challenge is, how do I know in nums1 which element I have to take to replace the first element so that it will reduce my overall sum, right? So that's the overall process we need to look at and understand how we can solve this approach, right? One is, so when I'm looking at this number, right, so what I have to find in this array, what is the lower bound of this 9 and what is the upper bound of 9, right? So because difference could be from the lower side or can be up from the upper side, right? So in this case the upper bound is 10 and the lower bound is 7, right? That's the lowest element. After 7 we get 9, and then after 9 we get 10. And if I take difference here, right, what is coming is going to be 2. And if I take difference here, so difference is going to be 1. So from this, what is the minimum one? So minimum one is 1. So that's that's the best difference I can get when I replace 1 by 10, right, for the 9th element. Same way I'll do this operation for the other elements in the array. For example, let's say 3, right? If I take 3, so what is the minimum bound for 3? So lower bound is going to be, let's say 2 here, and then upper bound is going to be 4. Now in this both the cases the difference is 1. So if I even take minimum, so that's going to be only 1 only. So in this way I'll go and try to figure out what is the lower bound and what is upper bound, and based on that I'll try to get the minimum differences. So that is going to be my best difference array. That's this one that I have calculated. But in order to do that, I'm going to use a Python function called bisect. So bisect will basically will help me to understand what is my minimum and what is my upper bound, what is my lower bound and what is my upper bound. So this is in this example I have just taken to explain, but in order to know that what is your lower bound and what is your upper bound, I'm going to use bisect left function, right? So in order to use a bisect left function, I have to sort an array first. So I'm going to sort my nums of 1. So nums of 1 will be like 1, 2, 4, 7 and 10. Now from the 9 I have to find out what is a lower bound and upper bound. So if I use bisect left function, so it will tell okay it's a lower bound, so it will basically tell only the upper bound. So then 1 minus 1 will be my lower bound. So I know this lower bound for 9 is 7 and then upper bound is 10. Now I'll calculate what is the difference here. So best difference is going to be 10, because from 7 I'll get differences 2, but from 10 I'll get differences 1, right? So I'll put it as a best difference. Same way I'll do it for other elements for 3, 5, 1 and 7, and then I'll get the respective best differences, right? So what we am trying to do is, by default without doing any change, the difference is coming as 7, 8 and 7, 1, 3, 5 and 3. But if I do this kind of operation, sorting, and then we try to get lower or upper bound, this 8 can be reduced to 1, right? So if my 8 is reducing, then overall sum will also reduce. If my 7 is reducing, then overall sum will also reduce. But remember, we don't want to reduce each and every element. We want to do only one operation. So in one operation, what is the maximum that you can reduce? So from here I can say that okay, in one operation, if 8 is coming down to 1, so what I am saving is, I am saving 7, and 7 is coming down to 1, what I am saving is saving 6. 1 is coming down to 2, there is no change, so there is no save here. 3 is coming down to 1, so I am saving 2. Same way this, right? So in this saved array that I get, right, so what is the maximum I can save? So maximum I can save is 7. So if I reduce 27 minus 7, so I'll get to 20, right? See, we don't need to tell what is the number you are replacing as a result. We just need to tell after one swapping what is the best what is the best minimum absolute difference you can reach to. That's when you need to tell. We don't need to tell okay I replace 10 or I replace any other element here. We just need to find out what is the maximum I can save, right? So that's overall logic here. I hope you understand. Let's look at a code. So in the code, I'll try to get this absolute difference first. So absolute difference is nothing but what is the default difference I have. So this particular row, 8, 7, 1, 3. So 9 minus 1, 8, 10 minus 3, 7, like this. So this is my default differences that I got. Now once I got this my absolute difference, I'll store the sum as well. This is basically 27 into one result sum variable. So that is my sum. Now I have to do a sorting so that I can use the bisect function. If I don't use sort, then bisect function probably will not give a correct result, right? So I started iterating on the so I started iterating, and then I'll use this bisect function on nums1 and nums2, and based on this, because n is basically length of, because both arrays it has equal length, so based on this I'll iterate on nums2, and then I try to find in nums1 array what is the position. So basically when let's say I'm looking for 9th, right, so 9th can be in so if you read about bisect left function, right, basically it tells about the position where the number can be inserted. So I would advise you go and read little bit of bisect left function. So it is basically tells about okay 9 can be inserted here, so between 7 and 10. So that is my position it will. So it will return position as this last one, the 10th position, and then -1 will be my left position. So now I got what is my lower bound for 9, then what is upper bound for 9. So this is 7 and 10. Now I try to calculate differences. So I'm calculating the difference here, and then what is the minimum out of those differences I'm going to store into best difference array. So this is my best difference array. I'm now creating it, which is 1, right? Same way I'll keep doing it. There are other condition I'm also adding. In case bisect left function is returning something which is at the first position, right? Let's say here at this particular first position, let's say it returns this position, or it returns something else which is here, right? Then in this case, this may give out of bound index arrays exception. So in that case, if it is returning 0th position, so I'll just do the nums of 0 minus nums of this, right? And then in case it is returning something more than the next position, let's say last position here after 10th, let's say here, then I'll just do -1 and then I'll take a difference here. So position -1, I'll take a difference and I will put it into best case. So that's this overall. That's the logic here. And then once I get this best difference array, I'll see what what is the amount I have saved. So what I have said is, so instead of 8 minus 1, that is 7. So I'll create this saved array, and then from this save I'll try to find what is the maximum. So maximum is this particular one, right? This is the maximum. So this is the maximum value I can save. So this max I'll divide it from subtract it from the sum that I had initially calculated, and then I'll return it, the result. Result should be written with the power mod of 2. It was written somewhere here in example. So 10 sorry 10 power 9 plus 7 is a module we have to take, so I'm doing that, right? So that's overall logic here, the algorithm. Hope you understand. So if you run it now, so it should probably work. So mainly I'm using bisect function, which basically tells where to insert an element, the position, and then based on that I'm trying to find out what is the lower and upper bound, and that works pretty well, I think. Thank you for watching. That's it for today. See you in the next video.